Let us start one very interesting and problem for the current context. Say Corona problem. Corona problem. Consider a 3x5 matrix. Say 3 rows and 5 columns. There are 3 types of elements: 2, 1, and 1. Sorry, 2, 0, and 1. And these are the current positions of the elements. Two stands for person affected by corona. 1 stands for not affected person. Zero stands for physical space. Physical space. The corona travels along the rows and along the columns. If corona affected person is adjacent to not affected person, the not affected person will be affected by corona. But if there is 0 adjacent to 2, then corona will not travel the physical space. So this person will not be affected by corona. If that person is separated by a blank space or a physical space, say 2, 0, 1, 1 is not affected. Say 2, 0, 1, 1 is not affected. Say 2, 0, 1, 1 is not affected. 2, 0, 1, 1 is not affected. Here in the first phase, this 1 becomes 2. This 1 becomes 2. In the second phase, this 1 becomes 2. In the first phase, this 1 becomes 2. This 1 becomes 2. This 1 becomes 2. This 1 becomes 2. In the second phase, this 1 becomes 2 and this 1 becomes 2. So it seems all are affected by corona. If anybody is left, return -1. Otherwise tell how many phases it took so that corona is, or every person is affected by corona. Okay, so let us solve it. Very interesting problem, isn't it? Let us go to a new file and start it. Okay, let us call this as matrix. So it has 3 rows and 5 columns. 1, 0, 1, 2, 1 is second row. The third row is 1, 0, 0, 1, 1. Okay, this is a 2-dimensional list showing the positions of people affected by corona, people not affected by corona, and physical space. Okay, now let M is 3 and N is 5. M stands for number of rows and N stands for number of columns. Okay. Let us create a node. Okay, with 3 members. Phase of corona, then location, and location has 2 parameters, x coordinate and y coordinate. Okay, now let us find out find out how many twos are there, how many twos are there, and where are they, so let us create a node, okay, with 3 members. Let us have one constructor, 3 members. You know the default and must parameter is self, comma. First one is phase, second one is x coordinate, and third one is y coordinate. Okay. So self dot phase is phase, and x is x. So we supply phase x and y whenever a node is created. Okay. This is class. Now let us find out how many people are affected by corona in the initial phase or 0 phase for I in range m for j. So let us call this as for row in range m, for column in range say n. Okay, n. If matrix row column is any element, initially 0 element, is equal to 2, then you create a queue which is initially empty. Here append to queue, QUEE, append to queue the node which contains phase. Say initial phase is 0, x coordinate is row, and y coordinate is column. Okay, that's enough. So queue is created. Let us see whether queue is created or not. For item in queue, print item dot phase, comma, item dot x, comma, item dot y. Okay, let us check. Let us save this somewhere, run it. So it shows in 0, 0 position we have a 2, and then in 0, 1 position, in 1, 3 position we have a 2. 0, 0 position we have 2. Let us check it. How many 2s are there? 2 2s are there. How many 2s are there? 2 2s are there. Where are they? At 0, 0 and at 1, 3. Okay, and phase number is 0. Okay, so hope you understand it. Let us zoom it. Now, so you have seen this. Now take the first element from the queue, have an infinite loop, and we break it when queue is empty. So the item or node is equal to from queue take the first element, 0th element, using pop function. Q is a list and pop is one of the methods. Okay, so let x is x coordinate of item. Let y is y coordinate of item. Okay, now if x is greater than 0, if x is greater than 0, what does it mean? X is first row, second row, and so on, but not 0th row. In this case, so we can go back. What do I mean is, we are in first row, you can go back to 0th row. Okay. Second condition is if y is greater than 0. Next condition, if x is last but one row. Next next one is if y is last but one column. Y is less than last but one column. X cannot exceed last but one row, y cannot exceed last but one row. Okay, in this case, if matrix x plus 1 and y equal to 1, then you replace this with 2. If it is 1 and adjacent to xy, it becomes 2. Okay, and to the queue you append a new node. Now this is previous phase plus 1, new phase. Previous phase plus 1 is a phase. X coordinate is x plus 1 and y coordinate is y. Okay. Now, if y is greater than 0, then so matrix, go to next column. The same row, x, y plus 1 is equal to 1. Then convert this to 2. So not affected is now affected. Okay, so this is matrix x, y plus 1, and the position is x and y plus 1. Okay, greater than 0, I'm sorry, you can go back, right? Minus 1. This is x minus 1. I'm sorry. This is x minus 1. This is x y minus 1. This is x y minus 1. And this is x y minus 1. Okay. Next case. This is going forward. Here x is less than m minus 1 and y is less than n minus 1. Okay, I go up to last but one row. Okay, This is x plus 1 moving ahead, and this is y plus 1. Go to next column. This is x plus 1, and this is y plus 1. This is x plus 1, and this is y plus 1. To find out number of phases, so assume a variable max, okay, and so if item dot phase is greater than max, then max equal to item dot phase. To know how many phases it took to affect everybody, okay. Next, so this is an infinite loop, you need to break it. If length of q is equal to 0, q is empty, then break the loop, okay. So done. Now find out, is there anybody left to be affected? So assume that count is 0. Whenever you get 1, increment count by 1. Say for row, this is for counting ones. For row in range m, for column in range n, if the element, what is the element? Matrix row column is equal to 1, then increment count of ones by 1, okay. Now if count is more than 0, print maximum number of phases, which is max itself, okay. Else print -1. It says that all are not affected, okay. Or print number of persons not affected, which is nothing but the count, okay. So done. Let us run this. What happened? Matrix, if y greater than 0 and matrix spelling MERTRIX, one more parenthesis here. So in every place, okay. Now let us run it. No, I should change the spelling of matrix at every, matrix, okay. Again, one more parenthesis here. Why parenthesis? No. single phase and single quote on one side and double quote on the other side. Let's check the other print statement also. Fine. So number of persons not affected, 0. And what about maximum? If item dot phase is greater than maximum, maximum item dot phase. If length of queue, okay. And what is maximum initially? Initially maximum is 0. If count is, I'm sorry. If count is equal to 0, count is equal to 0. Okay. So all are affected. It took 2 phases. Now let us do one thing. Let us make it 1. Now because of this one, this will not become 2. This will not become 2. Because this is not 2, this will not become 2. This will become 2. If this is 2, this will become 2. This will become 2. If this is 2, this will become 2. Okay. And how many people are not affected? 4 people. So let us do one thing. We also print the matrix. We also print the matrix to see the final position. Okay. Here, simply print the matrix. Say row, column, row, column. And I want all the elements of the row in one line. Okay, here, printing one row, leave a line so that next row will come in next line. Now, how many are not affected? 4 people. The reason is no corona affected person is close to them. Okay. Now see the input and the output. So because of this 2, this has become 2, this has become 2. Because of this 2, this has become 2. Because of this 2, this has become 2. This has become 2, and because of this 2, this has become 2. Okay. And because nobody is nearer to them, these 4 people remain unaffected. So number of persons unaffected or not affected are 4. Okay, hope you understand the solution. Thanks for watching. This is one of the most important concepts. I used here OOPS concepts, list concepts, matrices. Okay, so hope you liked it and understood also. Thanks for watching. Please subscribe. Good night.